HMS developer from Huawei India Research Center. Welcome to Develop with HMS Code. Today, I am going to explain about scenario-based graphics API of SceneKit, that is ARView. ARView uses the plane detection capability of AR engine together with the graphics rendering capability of SceneKit to provide you with the capability of loading and rendering 3D materials in common AR scenes. With ARView, we can load and render 3D materials in AR scenes. Set whether to display the lattice plane. Tap an object placed onto the lattice plane to select it. Once selected, then we can move, resize or rotate it. This demo gives the overview of how to use ARView in the fine-grained graphics SDK to implement functions such as placing a virtual object in a real-life environment. In order for ARView to recognize the ground, first you need to turn the camera slowly until the plane point you see in the photo appear on the screen. After the plane points appear on the ground, tap on the lattice plane to place object. As you can see, virtual object loaded is a 3D model robot. You can move the robot, change its size or direction as you can see in the video. Here, light shadow effect and animation is enabled to make the graphic more realistic. Now, let's get coding.
The following code explains how to implement ARView to load materials in an AR scene. First, open module level build.gradle under dependencies section. Add the dependency to integrate the main package and extended package of the fine-grained graphics SDK. And add dependency to integrate the UX package of the fine-grained graphics SDK. Add the camera permission in the manifest.xml file. The 3D model used in ARView is stored in the asset directory in .gltf format. All the files including the textures, scene.bin and scene.gltf of the 3D model is added here. After adding the materials, we first initialize the scene kit. Add the ARView to the layout. Obtain the ARView in the onCreate method. Set the enable plane display function to true to display the lattice plane. Then load the object to the view. For this we need to first obtain a resource builder. Set the target resource URI and resource loading options for the resource builder. Call the load method and set the load event callback. Obtain the loaded resource from the load event callback if the load is successful. Otherwise, obtain an exception. Add a camera and light to the component. Create a node and attach a light component to it. Set the light source to directional light. This light has been set to cast shadows. Add a listener for plane tap events. Load a model to the scene and returns the model public node. Obtain the transform component of the model node and set the node position and scaling. A model can both cast shadows and receive shadows. Whether a model casts or receives shadows is configured in the renderable component. As a model may contain multiple renderable components, it is necessary to traverse the descendant nodes of the model node. Next, obtain the animator component. Determine whether the model node has an animator component. If yes, the model contains animation data. Prepare to control the animation accordingly. Record nodes that support AR capabilities in AR scenes.
You have now successfully learned implementing AR View on SceneKit. Well, that's all for today's episode. If you have any questions, you can leave them in the comment section below or visit Huawei developer website. And be sure to hit the subscribe button. Thanks for watching.